Good morning, or actually good afternoon, everyone, and welcome to the Ohio Federal Research Network's webinar on our latest round of investment here in the state. This is round 6. If we could go to the next slide, please. This is the agenda I'm going to cover today. My name, by the way, is Mary Margaret Evans. I'm with Parallax Advanced Research, and I will be your host for the day. We will be recording this session, so it will be available to you later. We will post it on the OFRN website. So a few words to begin today about OFRN itself, but the main focus is really to look at the round 6 opportunity that we posted on 1st March and on the OFRN website. We will go through the process, what we're looking for at a very high level. In the proposals, we are asking people to submit, and then that will be followed by a little more in-depth discussion of the particular technical areas of interest. We are joined today by a number of our federal partners who've taken a tremendous amount of time to help identify and to articulate the needs that they see and the research that they are interested in. So we want to welcome all of our federal partners today. Thank you very much for taking time out of your busy schedules to join us. I'm going to go through this again at a very high level. If you will hold your questions to the end, we will have time to answer them then. Okay, next slide, Vicki. So a little bit about OFRN for those of you who are new to the program or not familiar with it, and a refresher for others. We have 5 federal partners, which you can see listed there on the left-hand side. So the Air Force Research Lab, the National Air and Space Intelligence Center, or NASIC, the Naval Medical Research Unit Dayton, or NAMRU-D, NASA Glenn, which is up in the Cleveland area, and of course, the Ohio National Guard. To date, the first 5 rounds have involved 21 universities and community colleges across the state and 97 businesses. Next slide, please. A little bit about the OFRN mission and core services. Our real goal is to try to move Ohio to be one of the top states in the United States when it comes to research and development funding. To do this, the state of Ohio has a very unique program, the OFRN, that helps fund research and development in core areas of interest to our federal partners, such that we can bring together statewide universities and industries along with those partners to pursue leading edge technologies and research, and ultimately, hopefully, lend and drive job growth here in the state of Ohio. On the right-hand side, you can see some of the services the OFRN provides. That includes commercialization and workforce development services, help making you aware of opportunities for follow-on federal funding, network, collaboration, and of course, education and training. Next slide. Here's a little bit about the program's impact to date over the last 5 years. I've already mentioned the number of universities and business partners, but if you'll look at the bottom, I think you'll see fairly impressive $51.4 million that the state has invested in this program to date. The follow-on funding for those that have been awarded projects is over $355 million. And we've spun out at least 13 companies from the federal partners who've participated so far. Next slide. So moving to the process for the request for proposal. Again, this was posted or released on our website on the 1st of March. And this is a nice high-level overview for you of what is in that particular request for proposal. The project teams that respond to this must include at least one industry member in 2 Ohio colleges or universities. The industry, college, or university can either be the lead applicant or primary applicant, or they can be one of the collaborators on the team. We will also connect you with one federal partner or sponsor, and you can see them listed there below. Financial commitment from the federal partner is not necessary, as this is a state-funded program, but we want you to know that we would prefer you not reach out to the federal partners directly. That would be a lot of emails that could get lost in people's firewalls. We will work with you to help connect you with that federal partner and or sponsor. Next slide. So projects must meet the following criteria. They must be applied research. That means that they should be science or technology activities that the government refers to as 6.2 or 6.3 efforts. And you'll be able to find those DoD definitions on the web. They also need to be at a technical readiness level, says review, but technical readiness level of TRL 3 or higher. There is detailed information in one of the appendices with the definitions for each of those levels. OFRN will not be able to accept basic or foundational research in this proposal round. Next slide. Projects must also meet the criteria on this page. University and college-based primary applicants, so the lead roles, if you will, must develop a technology control plan within 45 days of notice of award. And in addition, all primary applicants are responsible for export control compliance, which will mean including the identification of export control classifications of any of the projects and the people that are working on them. These folks need to be U.S. citizens or eligible to obtain the necessary export license in order to be able to participate in the project. Next slide. Proposals are due on the 28th of April, and these are the components. There is a technical proposal that can be no longer than 8 pages, a proposal supplement that is 2 pages in length, a cost proposal that includes a budget worksheet, an attachment of 2 pages that goes into the student experiential engagement, also a vendor profile, quad chart, and your TRL assessment results. All of this is explained, laid out in the proposal itself. Next slide. And here are some key dates. So the proposal was released on the 1st of March. We held our first webinar on the 2nd. This is the 2nd of 3 webinars on the 7th. There will be one more in April, and that will be on April 17th. Highlighted in yellow is March 14th, a mandatory bidders conference and proposal training. You can register for that training through the round 6 solicitation page on the OFRN website. And you can see that there at the bottom of the page. It will also be at the end of this slide deck as well. Going forward, we will accept questions about the proposal through the 18th of April. After that, no more questions. We will post frequently asked questions and answers on the website under our FAQ section, but the proposals themselves are due April 28th. We will notify the finalists on March 23rd, And then those finalists will meet with the technical review committee on June 12th through the 16th to answer a few questions about their submissions. And then awards will be announced in August. The goal is to have the project start in the September-October timeframe of this calendar year. Next slide. And this is just sort of a pictorial representation of the more detailed chart I showed you previously, for those of you that like pictures. All right, next slide. One of the things that's new to round 6 is a matchmaking capability. Again, the round requires 2 universities, 1 industry partner, and a federal sponsor. Many of you may say, well, you know, I really could use a partner to satisfy a particular requirement or to fill a technical gap. Likewise, you may have things that you can offer to others, prototyping a test facility, for example, or particular research capability. You will be able to make both those things known on the OFRN website under our matchmaking link. This is all anonymous. You will there be able to advertise what you need or what you have to offer. The OFRN staff will then connect you with folks that are interested in helping you fill your needs or interested in what you have to offer, and reach out to you and say, company X, Y, and Z is interested in partnering with you. Where you go after that is entirely up to you. You don't have to make those matches and accept those as partners, but we offer those up to you for your consideration. So that is a new thing, and I think you'll find that an interesting opportunity. Next slide. Again, the mandatory session is March 14th. So this is coming up soon. 1 person from each proposing team is required to attend. This will last a couple hours, and we will go over again, you know, a very high level, what the round is looking for, some of the matchmaking capabilities, but the focus really is on proposal training. What we found in the first 5 rounds is that those teams that go through the proposal training not only submit a higher quality proposal, but they are then really ready to go out and work with the federal government for follow-on funding. And that's our goal, is to help you do that if you so choose. So required training, March 14th, 9 to 11. Next slide, please. All right, now we come to the part I know many of you are really interested in. We are going to go through each of the AOIs, or areas of interest, and I'm going to ask the federal partners that we have speak for about 3 minutes or so in their particular area of interest. I'd ask that people hold their questions until after we've had a chance to go through and describe each of these areas. We have saved time at the end for both questions on the AOIs as well as the whole proposal process itself. So with that, let's turn to the first AOI on hypersonics. There are 2 issues in this particular AOI, which the first one here is gradient printed structures for high thermal gradient applications. Is Bruce Steinitz on?
Yes, Bruce is here. Yes.
Right. Over to you.
Okay. Hi, everybody. This is Bruce Steinitz from NASA Glenn in Cleveland. I'm leading the hypersonics discussion today. I have a couple other colleagues also. I'm not sure if they're on or not, TJ or my other colleague. The purpose of this first one is to look at kind of novel additive manufacturing printing techniques so that we can take advantage of modern manufacturing techniques to print very high temperature structures on the outside of a skin of a material of a vehicle, and then transition to a lower temperature material internally, with the idea that we would hybridize. So we would take advantage of the higher temperature materials on the outside. Those might be, in the ceramic category or others, or refractory materials, but then transition to lighter weight materials down below that could be more easily integrated with, the airframe body or superstructure itself. And there's several options that you can address here. One is the design and optimization, and I neglected to mention that in hypersonic structures we have a very high thermal gradient, where temperatures may get up to 2,500 degrees on the outside and 1,000 degrees or 800 degrees on the inside. So in a very short distance, we're dropping 1,000 or more degrees in temperature. So ways to optimize the structure and then optimize the printing to accommodate that would be very helpful. Process parameters for guiding the machine to do that. Obviously, depending on which technique, whether it's powder bed or a DED, ways of introducing the powder in such a way that you have the correct material at the right elevation to do this. And then, because these will be flying structures, we would like to be able to determine, the quality. So ways of doing non-destructive evaluation to look at those structures to make sure that they are of high quality. And then finally, Robert is on. We're also very interested in high temperature monitoring systems for monitoring the health of the structure for repeated cycling. So the whole idea, can we print or can we somehow integrate high temperature sensors into the structure, high temperature sensors into the structure so that we can monitor its health. So I think that kind of covers that. And then if you want to go to the next one. So there's a second subtopic here that addresses the need for novel joining and sealing techniques of hypersonic structures. These aircraft can be larger, and we know that there's going to be some joints within the vehicle. And so we're looking for ways of making a stable joint that doesn't tend to open up and cause excessive gap heating during flight. And we're looking for ways that we can seal that joint to prevent ingression of high temperature gases into the body of the aircraft. There's also a need for joining, for instance, things like leading edges that are extreme temperatures, maybe 3,000 to 4,000 degree temperatures at the very leading edge, and then transitioning that to a more modest temperature, say, 1,500 to 2,000 degrees Fahrenheit, some distance away, and then, making a solid joint, solid in the sense that it's not leaking between those two structures. And then obviously the need for high temperature flexible seals, 3D printing that would support these things, and then also techniques for joining thin metallic structures that are cost effective and that have good robustness so that with cycling they do not tear open. And then finally, the idea of embedding high temperature sensors to again monitor the health of those joints and those structures. That's all I had.
All right, Bruce, thank you very much. Next up, human performance. We have two issues here. Either Stephanie Warner or Frank Robinson.
Sure. So for this first problem, we're interested in non-invasive ways to detect and monitor ocular issues that are associated with spaceflight. as well as just general human performance issues that could apply in domains beyond spaceflight. So we want to be able to look at issues that are related to spaceflight-associated neuroocular syndrome, especially things like swelling in the optic nerve, choroidal folds, and cotton wool spots, and then also not just detect those things, but monitor and track changes over time. So there are kind of two main components to this area. There's the measurement itself that's looking for those types of indicators, as well as indicators of cognitive fatigue, workload, and impending loss of consciousness. And then there's the problem of taking that information and using it to actually generate some kind of an alert or an alarm and identify what that threshold should be without too many false positives or anything like that. That alert can be based on just the eye tracking metrics by themselves, or it could be in concert with other available signals like heart rate or respiration or things like that. Next slide, please. And then we're also interested in medical care in isolated environments. So as we get into longer space flights that go further from Earth, or potentially some combat situations where immediate evacuation isn't possible, we're looking for ways that can help somebody who has relatively minimal medical training. So not just a complete random person off the street, but somebody who has had at least a little bit of a background, somebody like a medic or a corpsman, who could, to help them diagnose and manage potential issues kind of on their own before help can get to them. So we're looking at like VR, AR type interventions that can help cue or guide that care provider. And it has to be something that is able to work in an austere environment. So, portable, ruggedized, and that can operate with little or no network connectivity or ability to communicate with anybody outside of that particular person who's providing care. And that was it for me.
That's it for you. All right, thank you very much. Moving to AOI 3, this is on high power energy conversion. And I believe we have both Chad Miller and Peter Kostek. I'm sure I said your name right, my apologies. On with us today. Gentlemen, would you like to review this for the group?
Yes, hello, my name is Chad Miller. I work at Wright-Patterson Air Force Base. I've been a civil servant for the last 18 years. Most of that time I've spent doing modeling, simulation, and hardware in the loop. The first topic today is called the affordable DC emulation and digital engineering. So this topic's both a DC emulator as well as a coupling to digital engineering. Digital engineering is taken off at Wright-Patterson Air Force Base in the last couple of years, and it's a capability that we're really honing and pushing. Certainly hardware in the loop is a process or path to implement digital engineering and try to get additional benefits. We are very interested in DC emulation. Most of the electrical power system in modern military aircraft run off of a DC bus. And the great thing that digital engineering helps us is we can fill missing pieces using modeling and simulation through a hardware in the loop experiment. So this first topic is essentially what can we do to develop affordable DC emulator. Current products, kind of commercial off the shelf, don't really address the digital engineering aspects. And we're really trying to get something that's quite capable, but kind of desktop size and more affordable so that we can make that an easier thing for both industry and academia to buy into. And we're looking to hopefully develop that as an ecosystem to get more novel and kind of interesting methodologies to come out of this. At the end of this result, we'd like to see a benchtop benchtop solution with a digitally engineered model that both work together to essentially fill in a hardware gap. I think that's it for the first topic. I don't know if my partner would like to jump in on the gallium oxide substrate development. Okay, go ahead.
I'd be better off from the first one. From NASA's point of view, I would just say that we are working on more electric aircraft and like turbo electric and hybrid electric. But we have the same kind of issues that you have. So a similar thing. I'm talking about the last slide here. Of building a DC emulator would be useful to us as well. But as far as the, I'm not really into the materials work or anything. So
I can briefly speak to it. Gallium oxide is a new chemistry, wide bandgap chemistry. It's showing a lot of promise. We're very much interested in seeing if there's any kind of capability or industry we can build up in Ohio, kind of fulfill some of the needs that we're seeing at the bench level researchers. Mainly that's to develop capabilities to develop the substrates and try to reduce the cost of those substrates. And we feel like this not only fits in line with a lot of our internal research, but also the expanding how you say micro device kind of electronics that's kind of happening in Ohio, and felt there was potential for some synergy there. And so we put this topic forward. If you have any questions on this, please reach back. We can get better information to you.
All right, we will get to questions, but thank you both gentlemen for going through this AO. Our next one is digital engineering tools. And I believe we have Rick Graves from AFRL and Stephen Zeck from NASIC. Gentlemen, would you like to cover this topic, these issues?
Steve, are you on? Well, so I'll just introduce myself. My name is Dr. Rick Graves. I'm also in AFRL RQ with Chad. So RQ, we kind of advertise ourselves as the Aerospace Systems Directorate. I'm sorry, as the integration directorate within AFRL. So as Chad was referencing, we are focused very much on digital engineering. And what we are primarily interested in is methodologies that look at different levels of model fidelity that would be applicable at different places through a system's life cycle. So that would go all the way from preliminary design through conceptual design up through even a critical design review. So as we go up that scale, and maybe we want to circle back. Maybe you look at a concept at a certain fidelity level for a certain amount of time. Maybe we want to circle back to lower levels of fidelity. It's all about accelerated product development for the things that we look at. So the hardware in the loop, software in the loop, application that Chad was referencing. There are different technology directorates in AFRL that are looking at standing up digital twin labs. So, methodologies that, are applicable to what those digital twins look like are things that we're interested in. In terms of the innovations in this area, we refer to tools, but in my mind, that extends also into methodologies, which may leverage, new tools or existing tools, as long as, we're able to represent what that tool chain looks like within, as we explore digital threads. Other types of software that maybe, have value there is methodologies that connect what I would call independent digital threads, because, there is an opportunity to accelerate product development if you're able to reuse artifacts that are output from a previous digital thread. Maybe in a methodology that might look at you leveraging AI to discover artifacts that exist in our ecosystem that are able to show value across multiple digital thread development cycles would also be of interest there. So I don't know if I admit to not having seen anything like an evaluation criteria, but I think my partner at NASIC, we were definitely wanting to see some application of these types of tools that we would deploy in our integrated digital environments to the other areas solicited by OFRN in this cycle. You can go ahead and go to the next slide. So, I also mentioned our other partner, at NASA Glenn. We pursue a lot of technology development programs between the three of us as we partner with industry and academia. So being able to have clear guidelines for what our authoritative sources of truth look like is what we want to get out of our methodologies. Now, the second slide here goes a little bit into what we're looking for or would be interested in terms of model validation. I have learned even since this was written up that maybe a better way to represent that desirement from the government partner is that we are interested in methodologies that demonstrate some type of approach to essentially digital model certification. What are the certification criteria that you could apply at different places in the product development lifecycle, and how those connect to some of the advertised Department of the Air Force maturity metrics. Again, there's also a set of metrics that are available from NASA. We're in the process of consolidating the Department of the Air Force metrics and the NASA metrics. NASA tends to be, and this is just my view, please reach out to your anyone at NASA you've partnered with before. They may be able to give you a better definition than I'm going to give you. But NASA tends to focus a little bit more on certification by analysis. AFRL is looking at digital engineering as well as the potential synergies and the Venn diagram that may exist there between digital engineering best practices and certification by analysis. We are interested in methodologies that explore from a digital transformation context above and beyond, what are the different combinations there that you could potentially look at? Because if you've seen a digital maturity assessment conducted, and we can provide that material to Mary Margaret, to OFRN, if they don't have access to that, we can certainly distribute that to proposers as needed if they want to see what the present digital maturity metrics look like. This is typically something that we apply to existing and new programs inside of AFRL. And that process right now is a little bit time intensive, is probably the low bar on that term. It can be outright, maybe intimidating to someone who hasn't seen that before and had to apply it to assess digital maturity. So innovations in these areas are, if there are new types of digital maturity metrics that you feel like has a role in the project that you want to explore, we would like to learn what that metric might be, what the nuance might be in terms of its application to a Department of the Air Force, or even I'll call it a DoD system of interest. That can have applications on either the commercial or the the defense side. But a workflow that shows how you would demonstrate the applications of the tools or the methodology that you develop, and this could be new software development. We would like to see that leveraged across as many organizations as possible to really get that maximum value back. So that's kind of all I had. I don't know if Steve had a chance to log in yet, but this is being recorded, so I can play that back to him and we can get his thumbs up that I tried to capture what we got out of our workshop back in January. Thank you.
All right, Rick, thank you. I appreciate that very much. Our next AOI, number 5, is commercial space in low orbit. And do we have Andrew Hamilton on today?
Yep. Hi, can you hear me?
Yes.
All right. Yeah, hi, I'm Andy Hamilton with the Manufacturing and Industrial Technologies Division from the Materials and Manufacturing Directorate in AFRL. Excited really to share with you some details on the ISAM topic, or in-space servicing, assembly, and manufacturing. Our interests really are in the latter two, the assembly and manufacturing. And this first topic here is really about, well, I think it's pretty self-explanatory, but to talk through a few of the areas we're interested in different materials, and those could be polymers, monomers, metals, and this idea of joining them together in LEO. So there's some gigantic challenges to overcome there, such as the zero gravity, microgravity, vacuum, atomic oxygen. There's a variety of other things that really lead to the hazardous environment. But in order to make some gains in this area of assembly and manufacturing on orbit, we really need to master this capability, and certainly having some capability from Ohio is fantastic here. Also, methods for doing this autonomously would be fantastic. Trying to keep the people out of the loop and humans out of there is highly desirable. Next topic. So another aspect of this assembly and manufacturing on orbit is this concept of biomanufacturing. And so really this is related to the use of bacteria and other organic matter to sort of repurpose materials. If you think about, the debris, maybe you've heard about lots of debris in LEO. There's some thinking that if you could sort of harness this debris and introduce biological material, you could essentially recycle that material and reuse it. So there's been a lot of growth in this industry terrestrially, and we're looking to see how techniques like this could support manufacturing in space. And I believe that's all that I had.
All right, Andrew, thank you very much. We appreciate that. And our last AOI is around quantum sensing technologies, and I believe John Leckie is here to talk about that.
Yeah, good afternoon. The quantum sensing technologies, just to give some folks background, at AFRL, there's a wide research interest in quantum sensors. And at NASA Glenn, we have a significant interest in quantum communication for sensor networks. So this topic is kind of a synthesis of those two strong interests between the federal partners. In quantum information science in general is a growing interest nationally. You have the National Quantum Initiative, and there are a number of areas where there's potential for submitting proposals for developing new technology. One of the things that has been coming up more and more is that folks are looking for really application-oriented quantum technologies. And so this is where we've tried to kind of focus this AO on the sensor technology. But we've also tried to give it a quantum information science more of an aspect to it. So while we're looking for a sensor that can demonstrate high levels of sensitivity, and it could be a magnetic field sensor, electric field temperature, it could be optical field, whatever. But we're also looking for a second aspect to it too, and one is either a minimal quantum processing study or a quantum communication study. And so the sensor is, we're hoping that the sensor would be developed as a physical sensor, but if folks wanted to demonstrate how the sensor would be interconnected through communication, they could do that through either developing a communication capability or doing modeling to show how that sensor would interconnect and
and achieve a quantum advantage. And then same thing for processing. While the sensor is requested, the physical development of a sensor, it could be possible that that folks would model how the sensor would utilize a primitive quantum processor for obtaining further information from the sensor. So the general idea is we're looking for the development of quantum sensors, but ones that would fit into quantum information systems where there might be a research development associated with it in processing, quantum processing, or in quantum communication. That's it. Thank you.
Great, thank you very much, John. We really appreciate it. And so now we will move into time for Q&As for these federal partners around these particular area of interest. And just so you can have those at your fingertips, here they are. We will do our best to answer anything you'd like to put in chat. And if you want to try to raise your hand, I will try to call on you. I also have two folks here supporting me, Becky Mesher and Emma Warner. So between the three of us, we'll hope to spot everybody who has a question. So with that, I will open the floor to questions on these AOIs. I see Daniel has a question. Yes, sir.
I had a question about the DC emulator. There are pretty fancy DC emulators from companies like Keysight that are available. Could you say a little bit more about what is lacking from COTS devices?
Yeah, so I think one of the biggest points is we don't just use these power supplies to provide a set voltage, right? And we have profiles or models that will drive that. And one of the lacking components of most commercial off-the-shelf solutions are either analog or digital inputs to either drive the power supply in a current mode or a voltage mode, or maybe even a constant power mode. And so there are some solutions out there that will do a profile, but generally those are limited in the time that can be driven to it. And so we would need something more continuous. Those are some of the kind of capabilities that I see kind of currently lacking. We also need to have a large controllable bandwidth because we're trying to get these power supplies to look like something that we can't get our hands on and integrate into the actual experiment, right? We're relying on a model to fill in a gap. And so the controllable bandwidth of these power supplies have to be greater than those pieces that we're filling in for. And this is a specification that can be kind of debated or talked about later. We would be very much interested in something that's 5 to 10 kilohertz of closed loop controllable bandwidth. Hopefully that kind of clarifies that gap.
Yep, thank you.
All right, I see we have a question from Andrew Hamilton. Andrew?
Yeah, hi. Actually, I'm just responding. I saw in the chat, Phil Putman, sorry, asked a question for AOI 5.1. Is the research emphasis more on the basic joining process, for example, welding, or an automation of the process? And so my answer to that is both. For example, welding is a type of solution for joining materials commonly used. You think of joining metals together, for example, but it is also ultrasonic welding, for other types of materials. We intentionally didn't describe the process, to see what kind of proposed ideas came out. But I would note that typically how we do that, when suddenly you're in vacuum and microgravities, it'll be much different. But so I think we're interested in either joining processes or automation of joining processes, ideally both. And that's all I had.
All right, Andrew, thank you. We appreciate that clarification. All right, I see Nicholas Hoffman.
Hi, yes. Quick question for AOI 4.1 on the digital engineering tools. Would a proposal be entertained that was heavily focused on MBSE development and comparison with actual classical methods of systems engineering?
Yes, yes, and yes.
Okay, thank you.
If they give me 3 votes.
That was the answer. Yes, yes, and yes. I see Daniel Gautier's got his hand up.
Yeah, this is related to topic 6 on quantum sensing. John, the topics that you've talked about are likely not going to be at TRL 3 from someone in the state of Ohio. And that was an issue in the previous round 5 of the OFRN proposals, in that there was a mismatch between what the reviewers expected for TRL and just what the state of the art is trying to hook up a small quantum processor with the sensor. Can you comment on that TRL mismatch? And is there going to be some accommodation for that in the review to realize these probably aren't going to be at TRL 3?
Yeah, I think, okay, that's a great point, Dan. So I should, I'll circle back and chat with the folks with OFRN and just make sure that we've got everything kind of aligned. And we do want to address that. The, in terms of the, you know, I think the kind of the important part for the, for this is that there be a physical sensor and there be a model or calculation showing that it would have an advantage, either, you know, with the processor or with communication. But that's a fair point. And so I'll circle back with the folks at OFRN and make sure that we have this kind of covered.
And if I could follow up,
yeah.
So what if I had a new detector technology for photons that allows us to have very efficient detection of photons in the mid-infrared that runs at room temperature? That wouldn't necessarily be a full quantum sensor system, but it would be a key technology for such a system. Would that be in scope?
Yeah, what I would suggest is that I think that, you know, the topic was kind of synthesized into having a QIS approach. So I think the detector definitely could be part of the sensor, but perhaps maybe with some sort of idea with integration with a, you know, telescope, or, you know, yeah, and kind of a model associated with that, maybe like some sort of, you know, VLBI model or something like that. Does that help? Okay.
Yes, thank you.
John, if I could ask on that particular one, after you've gone back and talked to some of your colleagues, if you would give us an answer that we could post then on the website, I think that would be very helpful.
Yeah, that sounds good. And I think I'd really need to chat with the folks at AFRL to make sure that we have that right. So, but that's a great point Dan brings up.
Okay, I appreciate that. Thank you. Yes. There's a Mr. Alexandrov with his hand up.
Yes, thank you. I have questions to the hypersonics topic. There are several items listed in both topics. Is it recommended including some of them, all of them, or addressing one item in a proposal is acceptable?
I think those proposals that address, this is Bruce Steinitz, sorry, from NASA Glenn, those proposals that address many of them will probably score higher, but certainly innovations in any one of those vectors we realize are kind of challenging problems would certainly be you know, welcome as well, if that makes sense.
Yes.
Yeah.
And the other question is, if let's say one university applies for two different the two different topics in hypersonics or similar research team, would it be acceptable, or what do you think?
I'm not sure if I quite followed your question. Could you say it again? I kind of got lost. Sorry.
Right. So if one university or one PI applies to two topics, the two topics in hypersonics,
Yes.
or one of the PIs is leading in one topic and included in the other topic, is this acceptable for the program?
Okay, so let me see if I repeat it correctly. Let's say University A is leading in one topic with University B as a partner, and then they flip roles in like the other submission. Is that sort of what you're saying?
Or University A is a leader in both topics. So both topics. So both topics.
See.
What
Okay.
do you think?
I'm okay with it. I guess I'll put it back to OFRN staff to see if they're okay with it.
I see. And my last question, at what point we'll get your contact information so we can start discussing particular aspects?
Sure.
There,
I think
I can answer. We're asking people not to reach out to the federal partners directly. We will give you a link to post your questions, and we will make sure the federal partners get all of those. And to the degree they're asked frequently, or we think there's broad interest in the answer, we will also post those as well.
So the questions and answers will not be private. This is what you're saying.
That's probably correct, yes.
Okay. Okay, because it's important on
Right.
the proposal development aspect.
Is simulate to the degree possible the same process that you would go through if you were submitting a proposal to the federal government. And there, the questions are all posted. They are all made.
Okay. And my last question, can we ourselves assemble a team, or we need to go through your team matching application?
You can assemble a team on your own. You do not need the matching services. This there to help.
Thank you very much. That's all.
Okay. I see 3 more hands. Let's go through those quickly. I know there's other people that have questions in chat. We may not be able to get to all of them, but we will get answers back for you on all the questions that are in the chat. So with that, let me go to Timothy Wolf. I see you have your hands up.
Yeah, this is on topic 3.2 on the barium gallium oxide. And apologies if this is redundant. I came in just a little late on here, but I did see in the document on the opportunity announcement, you're looking at protocols for testing these gallium oxide substrates. And is that more looking for procedures or for metrics that would indicate poor substrates?
This is Chad Miller. I believe it would be both or either. So I think part of the concern is just getting high quality substrates, but then making sure that you did indeed get a high quality substrate.
Okay, thank you. And are we going to get these slides or the recording of this webinar?
Yes, these slides and the webinar recording will be posted on the OFRN website.
Fantastic. Thank you.
All right, we have 2 more hands up. So quickly, Phil Putnam and then Aaron Chow.
Thanks. I had another question on Area 5.1. Just wanted to confirm that that's targeted toward permanent join-in as opposed to some kind of like modular attachment or just using fasteners. Something like that.
So I think we would be open to either option there. I can see a use case for both options there.
Okay, great. Thanks.
Yep.
All right, and Aaron Chow.
All right, I've got a couple of questions around the digital engineering tools. So the first part is that last bit of the solicitation is asking for using the surrogate models and deployment in the area solicited by OFRN for this round. Is this like something where, okay, we should be looking at focusing on one topic and pick one topic and demonstrate that we can do it? In my head, building a gradient enhanced surrogate model is going to be a lot of work, and being able to demonstrate on a thermal gradient application versus ocular degeneration would be quite a different application. So I guess the question is, is it, how many things should this model be doing in order to demonstrate feasibility that an AI enhanced surrogate model would work?
Yeah, this is Rick. I would develop the methodology and I would pick an application there.
Okay, perfect.
Pick one that you want to focus on. And because having those models, so for example, I mean, if you want to put a human inside of a hypersonic reentry vehicle, right? A model you might develop, maybe you have a methodology, you would develop maybe a validation strategy or a digital certification strategy for a set of models you want to maybe develop. Maybe it's an MBSE, maybe it's not. But if you wanted to show the traceability then of the models you develop in, say, Area 2 to Area 1, maybe we want to know the effect of reentry. We want to ask the digital question, what's the effect of reentry for a manned versus a unmanned hypersonic glider that achieves mission objectives A, B, or C? There's a way there to connect those two focus areas. And that's just one example. If you want, but I'd love to see what people come up with actually for number 6, right? Because we like to have the ability to evaluate new technologies before they get to the ground testing or even into the demonstration phase. Over.
Yeah, so that leads actually to my second part of this question. So on the training side of things, if we're doing AI enhanced models, is there an expectation that we'd have 10,000 pieces of data, 100,000 pieces of data? And sort of the second half of that is, how would we be validating these models at the end of the day? Are we physically testing, or are we running this through an ANSYS simulation and see if it comes up with the same solution 100 times faster, or something else?
I think coming up with novel strategies for achieving digital model certification is one of the things that we would be looking at from different proposals.
Okay, perfect. Thank you so much.
Yep. Bring your secret sauce. Over.
So with that, because we have so little time left, I'd like to move away from the questions around the AOIs. If we haven't gotten to your particular question, we will endeavor to get an answer for you and get that back to you as well as post it. So if we could, Becky, we move to the next slide. I'd like to leave a time for just general Q&As on the process itself. Maybe the next slide. Any questions on the process part of the proposal, round 6 proposal, or questions about the key dates? I see Mr. Razavi.
Hi, yes. This is Ruz Berazai from Kent State. I had a question about the matchmaking process and the timeline involved. So generally, how long do you think it would take for those interested in that service to be notified, given the limited time available for making the final proposals? So do you have any timeline in mind?
We are going to monitor the inputs daily. As soon as a match is made, we will reach out to you that day, and then you can take it from there. If there's no match, then you wouldn't necessarily hear from us, or we could tell you there's no match.
Thank you. I appreciate it.
All right. Let's see. Amy Magnus, excuse me.
Yes, that's me. Well, I feel that the AOI 4 is very different than what solicitations that OFRN has done in the past, and I think it would be very helpful for OFRN to step through its criteria in an FAQ on how it would evaluate, because truthfully, it sounds less applied and more basic research.
Well,
So-
let us take that back and get an answer and post it so that everyone will have an answer to that.
Yes, that would be very helpful. I appreciate that.
All right, we'd be happy to do that. I see Timothy Wolf's hands up. Or was that up?
Yes, so I am at Air Force Institute Technology, and which is sometimes both academic institution and federal institution. We kind of wear both hats at the same time, depending on who's asked. So given that, as I understand it, we need 2 universities, one of the federal partners and a industry partner, is that correct, for these proposals?
That is correct.
Which would AFIT be considered?
AFIT would be considered academic.
Okay, and this may be a question I'll need to direct to our own proposals office, but would this require then a CRADA agreement between ourselves and the federal partners?
I don't believe that's the case. We can clarify that back in an answer to you. The funding for this is coming from the state, not from the federal government. This is classified work, not classified. So I'm not sure a CRADA would be necessary.
And AFIT's also led solicitations and also actual projects. There was an AFIT-led, AFIT was one of the lead partners in one of the facilitations that went through round 1. So sorry about that. That's just Amy Magnus chiming in. So our office, should be able to help you with that.
And CRADAs, just so you know, the way they're designed is if you have a CRADA with AFIT, then that requires AFIT to put something into the research. And then you would put others, but if they are part of your team, then they would be considered academic institution.
Right, okay, thank you very much.
Okay, all right. I know we've got a couple more hands and we're sort of running out of time, so I will take Aaron Chow and then Mr. Alexandrov. Aaron? You had your hand up?
Sorry about that. Didn't drop it from from before.
Okay, and how about Mr. Alexandrov?
Yeah, a quick question. So we need a federal partner, but I think this would be the lead for the particular topic, or do we need to identify someone? Like,
we will work with you to connect you with the federal partner that and the subject matter experts for that particular AOI.
okay, so for example, for hypersonics, this would be NASA Glenn, I guess.
For most of these topics, you have both a NASA partner, an AFRL partner, some cases NASIC. It varies from topic to topic.
Oh, okay. So you'll make this connection. We don't have to.
We will work with you to do that, yes.
And last question, I see the request for proposals, these appendices 2 through 9 through 8 are essentially missing. Where can we get this from?
They should all be on. If you look at what's now showing, you will see a link there for round 6 solicitation. That should have the proposal with all of the appendices.
Okay.
And
yeah.
below it, you will see a link for frequently asked questions. Any questions we've not been able to answer in this webinar, you can go to the link at the top and submit your questions, and we will get you an answer and post it also as well. All right, one last question. We are running over time. I do apologize. I see, I know I'm going to mispronounce it. I'm sorry. Yushu?
Yes, it's me. Can you hear me?
Did you have a question?
Yes, I do have a question. My question is actually for Bruce and for the AOI 1.1. So I saw the solicitation mentioned there are powder bed fusing 3D printing. I just wondering whether you are considering other 3D printing technique as well. And also, can you comment about the thickness about this protection layer you are looking for?
Sure, I'll take the first question first. Yes, we are open to either powder bed or DED or any technique that you might propose. That's question one. And then question two had to do with the thickness. Is that what you said?
Yeah, I saw there are some suggesting the thickness need to be less than 2 inch.
Yes.
And just wondering what would be the typical thickness you are looking for. I know some technique might have thickness limitation, and I would like to match with what you need.
Certainly. So we're going to give you, some latitude for getting this done. And we're just giving that notional thickness of 2 inches to indicate that we have to drop a very large temperature in a very short distance. So the 2 inches was just to frame it. It's not 2 feet. It's inches. It's not feet. So I wouldn't get too hung up on, oh, it's got to be 2 inches or it's got to be, this or that. We're just trying to portray that it's a relatively thin dimension that you have to work with to go from a very high temperature to a low temperature. Does that help?
Yeah, that helps. Something like a millimeter or less than 1 inch, is that thickness also under your consideration? Or
so I'm anticipating that without that you might have high temperature material A at the surface. It might be millimeters thick, and then you might transition to another material of millimeters thick, and so on and so on.
Hey. Okay, yeah, understand. Thank you very much. Yeah.
Sure.
All right, with that, I would like to thank everyone for participating today in the webinar. Special thanks to all of our federal partners who once again have taken time out of their busy schedules to come and chat with us. They've put a lot of time and thought into the various AOIs, and I hope their explanations and answers were helpful. Once again, see on the slide where you can submit questions, where you can find the solicitation if you haven't seen it, and then the OFRN website where all of these are posted, including the frequently asked questions. As a last reminder, please put March 14th on your calendar. That is the mandatory training. This is the bidders conference and proposal training. We hope to see you all there. So with that, I will thank you all again, and I hope this has been helpful. Thank you very much.